number 14, this is from practice test 1 and the no calculator section. And the test gets harder as it goes through the multiple choice. So 14 and 15 should be like the hardest couple of questions for this section of the test. So here's the deal. If you have variables in the question, you may be able to do this. If you have variables in the answer choices, which we don't have here, but if you do, you can do this literally every time. It's not the only way, but it's definitely a way every single time. Okay, so what is the approach? Well, all we're going to do is pick numbers here that make sense of this equation. 3x minus y equals 12. Okay, well, I don't know. I'll try a couple really sort of snarky moves. I could try x is 4, and then what would y be? Well, 3 times 4 is 12. 12 minus y has to equal 12, so then y would be 0. I'll give you a few options here. X is 5. Let's try that. If x is 5, we have 15 minus what? 3 would equal 12, right? So y is a 3. And I'll even give you one more approach just to show you how this works, even on maybe a harder question. I don't know if this, I've never tried this number before, but I'll try it here. What if x is 6 and we have 18, right? 18, and then this is a 6. 18 minus 6 would be 12. So if x is 6, y is also 6. Interesting. Okay, so my goal here with using smaller numbers like 4 and 0 and 5 and 3 is that these exponents are going to be easier to work with because we don't have a calculator, right? So here's the deal. 8 to the power of x, that's 8 to the 4th power. 2 to the power of 0. Well, 2 to the power of the 0 is the same thing as, is just equal to 1. Anything to the 0 power is 1, which is kind of weird. But this is 8 to the 4 over 1, which is just 8 to the 4. And you might be saying, hey, Jeremy, there's no answer that says 8 to the 4. Yeah, but what do we know about 8 to the 4? Well, it's definitely not 4 to the 4. I'll put A, B, C, and D down here. It's definitely not 4 to the 4. It's something else to the power of 4. It's definitely not 8 squared. It's 8 to some other power, right? So it's certainly something that can be determined. We just determined it. We just don't know which number it was, so now it's answer choice A, right? I'll try it with these other numbers just so you can see how that same process works. So if x is a 5, we'd have 8 to the power of 5 over 2 to the power of 3. Well, 2 to the power of 3 is 8. So now we have 8 to the 5 over 8 to the 1. So now we need to know our exponent rules, which is if you have the same bases, you subtract the exponents. 5 minus 1 is 4. We're back to the exact same place. 8 to the 5th over 8 to the 1 is the same as 8 to the, maybe I could write it this way, 8 to the 5 minus 1, which equals 8 to the 4. Right, and we're in the exact same place we started. I don't know how it's going to work with 6 and 6, but let's just try it for a second. The thing is, I don't know what 8 to the 6 is, right? So this is an approach where if we use these too big of numbers, it wouldn't make sense, right? Because I don't know what 8 to the 6 is, nor do I know what 2 to the 6 is, really. I mean, I could figure it out. I could figure it out that I think it's 64. So this would be 8 to the 6 over 64. But 6, that looks like 6 to the 4. 64. Look, that's not that easy, except you could say, okay, well, 8 to the 6 is 8 squared times 8 to the 4. And this is 64. Well, look, this is a 64 too. 8 squared is 64. So 64 and 64 cancel, and you get back to 8 to the 4th. So when you pick big numbers, it's not really the smartest thing to do. You pick the easiest numbers to work with. And in this case, 4 and 0 worked, 5 and 3 worked. The whole thing was pick numbers that work right here. The way they want you to do this question originally, just to show you how challenging it is they want you to recognize that you can change the base of 8. They want you to recognize that you got 8 to the x over 2 to the y, and that's equal to 2 cubed to the x over 2 to the y. And then you say, oh, well, that's 2 to the 3x. You just multiply the x in times 2 to the y. Okay, and then you say, well, look, now I can subtract these exponents because I have the same base, 2 and 2. So 2 to the 3x over 2 to the y is the same as 2 to the 3x minus y, which we already know what 2 to the 3x minus y is. It's 12. I have very rarely seen even very smart people do that approach. And if they have, it usually takes a little while. So when in doubt, use real numbers.